Okay, in this video, let's talk about some ionic and some net ionic equations. First one we're going to look at is ammonium sulfate and cadmium nitrate. So we're going to have to first take these equations and we're going to have to break them up into their ions. So I'm going to take my ammonium sulfide and break that up into two ammonium cations, plus my sulfur cation right there with a -2 charge, plus my cadmium cation, plus two nitrates with a -1 charge each. Now, this is going to be a double displacement, so that means that essentially the sulfur and the cadmium are going to be reacting with each other, as well as the ammonium and the nitrate. So when I take those and I put them together, I have ammonium nitrate, that's going to be aqueous. Anything with ammonium is going to be soluble. Same thing with nitrate. Plus cadmium sulfide. Sulfides are going to be insoluble. This is not one of the exceptions. So essentially, this entire solution here is going to be aqueous, so I can kind of cancel those ones out. Those are my spectator ions. So what's left is my net ionic equation. That's going to be the sulfur, aqueous, plus the cadmium, reacting to form the cadmium sulfide, which is going to be my insoluble precipitate. Next up, zinc nitrate and ammonium sulfide are going to react in aqueous solutions. So I'm going to first take those and break them up. So my zinc just has a +2 charge on the cation, plus two nitrates, each with a -1 charge, plus two ammonium with a +1 charge there, and my sulfur anion. So the nitrate and the ammonium are going to be reacting together in a double displacement reaction. The zinc and the sulfur are going to be reacting together as well. What I'm left with is ammonium nitrate, that's going to be aqueous, and zinc sulfide, that is going to be my insoluble precipitate. My spectator ions are going to be the nitrate and the ammonium because those are not going to be changed throughout the entire reaction. What's left for my net ionic equation is going to be zinc plus the sulfur anion is going to make zinc sulfide, that is going to be my insoluble precipitate. All right, so here I have another one, strontium chloride plus potassium sulfate is going to make strontium sulfate plus potassium chloride. Here I'm breaking it up now into its constituent cations and anions. Same thing I'm going to do at the end, but I'm not going to do it for here because this is going to be my insoluble precipitate. And then of course I have the potassium chloride, that's going to also be in the ion form. Now I can cancel these out because these are going to be my spectator ions. They do not change from beginning to end. So the net ionic equation is going to be the strontium plus the sulfate is going to make strontium sulfate, and that is going to be my insoluble precipitate. All right, last one, sodium carbonate plus calcium chloride is going to make sodium chloride plus calcium carbonate. So I'm going to break this up into its constituent ions. Remember, if there's ever two there, I need to split that up so I have two of them for my coefficient. Once again, looking at this, my calcium carbonate is going to be my insoluble precipitate, which means everything else that doesn't go into making that, those do not change from beginning to end. Those are going to be the spectator ions. So my net ionic equation is going to be carbonate with a -2 charge plus calcium with a +2 charge is going to make insoluble calcium carbonate.